Cauchy's integral theorem, that is, if f of z is an analytic function. So as we discussed, analytic function means which is continuous and its partial derivatives are continuous and it satisfies the Cauchy-Riemann equations, and its derivative f dash z is continuous at each point within and on a closed curve C. So let this be a closed curve. Okay, so let this be a closed curve. Then this function, whatever function you define, f of z, is continuous, means at each point on this curve, suppose it is a circle, then f of z is continuous at each point of this circle. F of z is continuous at each point of the circle, and means each point on the circle and within the circle. Okay, f dash z is continuous at each point on this curve and all the point inside the curve. If it is means there does not exist a point where f dash z is not defined, then that function is continuous everywhere on the curve and inside the curve. If it is like that, then integral of f of z along this curve will be 0. That means, a simple example, if I say, suppose I define f of z is equal to, say, 1 by z in 2, 3. F of z equal to 1 by z in interval 2, 3. So, whatever the value of z between this interval, in this interval 2 and 3, whatever the value of z, this function will be always continuous and its derivative also. Its derivative means minus 1 upon z square. So, its derivative also will be always continuous. Means it always exists and it will be always continuous, because between 2 and 3, there is no value such that when you put that value here in the denominator, you will get 0. Okay, so there is no such value. So 2 and 3, between 2 and 3, there are an infinite number of values. You put any value to this z square, for each value, this f dash z will be a finite value. You will get a finite number there, you will get a finite value there. Okay, so what we can say is, that means it is continuous. Now, if I define, suppose this f of z is equal to, it is defined in a curve. F of z I am defining in a circle. I am defining this one. F of z is equal to, say, I am defining it as z 1 upon z minus 1 or z minus 2, whatever. So, suppose I am defining this function in the interval 2, 3. Okay, in this 2, 3, I am defining this one in this interval 2, 3, or normally we do not take this coordinates for this one. Suppose mod of z is equal to, say, 1 by 2. I am defining this f of z is equal to 1 upon z minus 1 in the circle mod of z equal to 1 by 2. So, this circle means this is a circle with center 0, 0 and radius half. Okay, center 0, 0 and radius